In this video, we will do three things. First, we will understand how insertion sort works step by step. Then we will see its code implementation. And finally, we will analyze its time complexity. To sort an array of numbers using insertion sort, the idea is to keep the left part of the array always sorted by inserting each new number at its correct position. We do this by shifting bigger numbers to the right to make space for the new number. In each iteration, we follow four steps. We pick the first number from the unsorted array. Let's call it the key element. We compare it with the numbers in the sorted array, one by one, starting from the rightmost element. If the number we are comparing is larger than the key element, we shift it one position to the right. When we find a number that is smaller than or equal to the key element, we insert our key element right after it. We repeat this process until the entire array is sorted. Let's see this in action step by step by an example array. We assume the first element 3 is already sorted. We also arrange the next element 29 after it as 3 is smaller than 29. Now we take 21 as our key element and compare it with the 29. Since 29 is larger, we shift 29 one position to the right. Then we compare 21 with 3. Since 3 is smaller, we insert 21 right after 3. Next, we take 16 as the key element and compare it with 29. Since 29 is larger, we shift it to the right. Then we compare 16 with 21. Since 21 is also larger, we shift it as well. Then we compare 16 with 3. Since 3 is smaller, we insert 16 right after 3. Next, we take 18 and follow the same steps. Compare it with each number to its left, shift larger numbers to the right, and insert 18 at its correct position. Then we take 20 and finally 4, repeating the same process. Let's enjoy watching the algorithm sorting the rest of the numbers perfectly into their places. Now that we have seen how the algorithm works visually, let's quickly see how it's implemented in Python. In our sorting function, in each iteration of the loop, we take the next key element, compare it with the elements on the left, shift larger elements one step to the right, and insert the key element at the correct position. Insertion sort runs in big O of n square in the worst case, but it performs much better when the array is already sorted. In the best case, it runs in big O of n. Thanks for watching. Please like this video if you enjoyed it and subscribe for more videos like this.